Hi guys, welcome to the second video of hybrid resonances. I want to discuss right away the structure of SO4 double minus. Okay, now we do know that the structure of SO double sulfate anion, so to speak, SO4 double minus is this. Oh my bad. Is this, and we're going to use BDFC to convert it to one of the resonance form, which is replacing the negative bonds with double bonds. That is the BDFC format of the Lewis structure for SO4 double minus. And I kind of know that there is these oxygen negatives. I could take one of them, put it here, and put the negative charge. Actually open up the double bond and put the negative charge on this oxygen. I could do a combinations of those, and in doing so there are literally 6 possibilities of which of these two oxygen are going to be negatives and which two are going to be double bonds. How do I discern that? In a tetrahedral geometry, that the geometry for sulfate anion, these two could be, two on the back could be actually the one that becomes, so let me just put it in a way that you guys all could see. Yep. So these two could be the one, these two could be the one, these two could be the one, or there's a possibility of these two over here, these two over here, and these two. So literally 6. 3 that I have drawn with the green marker on the bottom, and the 3 that I'm just showing with these other markers here. So let's just go on and try to very quickly draw all those forms. Let me see the screen. Let's check. So these are those tetrahedrals, and I want to make sure that I could do first the 3 on the bottom. So O negative, O negative, O negative, O negative, or O negative, O negative. Then the 3 on the lateral side, O negative, O negative. Now this one, O negative, O negative. And now the last one, O negative, O negative. And then I go S, O double bond, O double bond, S, O double bond, O double bond, S, O double bond, O double bond. Let's just get rid of this. S, O double bond, O double bond, S, O double bond, O double bond, and S, O double bond, O double bond. Those are the 6 resonance forms for SO 4 double minus. And if I just do one over here, a big one, let's see if everybody can see this, and I'm going to, yes, that's in the good place. So this is my hybrid resonance. Now first the connectivities, and then let's do, because we know it's symmetrical, let's go on this oxygen and on this bond, literally down in the middle, and just focus on that one for both charges and partiality. So there's a double bond here, also a single bond, also a double bond, a single bond, a single bond, and a double bond. So it's flickering between double and single. It's double, 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 and single, single, single. So you could just say anytime we look at this, it's going to be single. Sometimes it's a double, so we do a partial bond for the second one. And let's now focus also on the charge. There are 6, so we divide the sum of the charges by 6. And let's say no charge, -1, -1 still, -2, -3, and -3 as well. So a third over -3 over 6, or a half, a half, a half, a half, a half. So you could see that we have these sort of charges for this, and we kind of have a resonance structure for sulfate. That is, if you sum up the charges, 4 halves would make the exact -2 charge that you have. Let's move on to yet another structure. I'm interested to do the one that is acetic acid with the structure CH3CO negative. There is just one other resonance form doing this, and that would leave this oxygen chargeless, making it a double bond with this carbon, and thereafter it would rip this bond up, put those 2 electrons for the oxygen, so it becomes O negative. If you continue to do that, you would get the same exact resonance. So the resonance form are just 2. The hybrid resonance would then be, that's the connectivities. Well, this CH3 is just an spectator. The motion is in this part. It goes back and forth between the 2 oxygens. So let's focus on the 2 oxygens, and they would be symmetric, like 2 of them would be the same. Let's focus on this one, 0 charge, -1, so -1 divided by the 2, -1/2, -1/2 exactly. Let's look at the partial bonding. There are a double bond here and a single, so it goes between a single and a double. So every time we look at it, it would be a single, sometimes a double. Also the same exact story for the one on the top, and that's the hybrid resonance for acetic. This is the acetate anion, okay? So that's the hybrid resonance for the acetate anion. We'll kind of abbreviate this thing to ACO, with this whole thing being the AC functionality, and ACO negative is acetate. Also, the ACOH is the acetic acid, the basic ingredients of vinegar. Let's move on to yet another example that I'm eager to talk about, the O3 molecule. So O3 is the ozone molecule. That's the Lewis structure for ozone. A trigonal planar with one lone pair, so it's kind of bent. And then we want to do ORFC here. That would be a given. So I just changed this to a normal bond where I had the tip of the arrow. I put -1 oxygen. It used to be the head of the arrow, so I put the +1. So now this is the ORFC structure that I could start taking it as one resonance form. There's also one more resonance that I could do this, and that would then be a steel O positive, double bond, charge is gone onto this bond, and it would kick off this one and put the 2 electrons on this oxygen, leaving this bond as a single one. So I could now go and say my resonance, my hybrid resonance then would be, okay, so this is a double bond here and a single bond, so it's going between single and double. It would be partial. Also this would be partial. And then on the charges, there is oxygen. The middle oxygen is always plus, so it doesn't change. It's just literally the spectator. This oxygen is 0 here. It's negative, so -1 divided by the 2 resonance form. The same exact story can be told about the second oxygen. So that's the resonance form. And if you look, the charge is just 2 negative halves. That would be cancelled up with this positive charge. So there's ozone as a neutral molecule. Let's move on. With oxalate anion, C2O4 the structure is like this, with both carbons being sp2 hybridized, so trigonal planar. And I could see that when the negative charge moves to this central carbon, there are not 2 passes, but just 1 pass, because the reverse or the flow of electrons could be only done in sort of, let me just get rid of this, I don't know why it makes me mad on this. Okay, I should get rid of this oxygen. Retry it. It can't actually flow on a single bond. There should be a double bond here, so the charge, this negative charge, cannot move to the other place. So you cannot have a structure that have both oxygens on one side and negative. So there would be four different structures. I could put this oxygen as here. You could see that if oxygen goes to the top, let's just see how it works. This would remain as it was. This becomes O double bond and O negative. So you could have both oxygens on the top, both oxygens in this word cross-rotated, both oxygens on the bottom. And I'm talking about O negatives when I say oxygens. Both negatives oxygen, that's what I mean. And also both oxygens in a slash manner, so sort of a back slash and a slash. So that's all the possible resonance form that we could have. We can't have any other structure that have both of the negative oxygens on one side, and that's because the negative charges cannot move where there is no conduit. There's a single bond, so that's a stop sign for motion of the charge. The charges are moving up and down on this side and also up and down on this side, and the four combinations are the ones that's shown here. Let's do the resonance form with the connectivities first. So now I want to talk about the resonance forms and the connectivities. I could see that, okay, now that I have this, I have a symmetrical structure. I could talk about only one of these oxygens and relate it to the other. 1, 2, 3, 4. So it's -1, 0, -1, and 0. So 2 negative, -2 divided by 4. And it's -half. So -half, 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 -half. And then if you see, it's a double bond, a single bond. I'm talking about this CO bond. Again a double and again a single. It's flickering between a double and a single. So anytime you look at it, there is a single bond. Sometimes there is also a double bond. So we do this partial thing for that sometimes. And that's the resonance form for this kind of oxalate anion. Let's move on. A very similar case is here that I want to discuss right after this, because it's very similar and it's going to be with stock in your mind if I do so. That's the structure of N2O4. We all know that this is the N2O4 structure, and what I want to do is to actually use this structure of N2O4 to actually do an ORFC and see what I could get with ORFC. There would also be 4 resonance structures if I do so, because as soon as I draw the first resonance structure, you kind of see how similar this is to the structure of an oxalate anion. Okay, now everybody could see that it's kind of a backslash. I could have also a slash version, a top version, and a bottom version. So that's what I get, the 4 resonance form. Again, that's the same story. I could move this one and this one, and I could get this one with 2 oxygen negative on the bottom. This oxygen becomes chargeless, and here it becomes a double bond. This double bond is now gone, so it becomes a single bond, and the electrons concentrate on this oxygen, so it becomes O negative. You could get all the other four, and the negative charge cannot move from this side to the other because of the single bond that sort of acts as a stop sign that actually hinders electrons from traveling to the other side of the molecule, so you can't have a resonance form with two oxygen negatives on one side. That's the four possible resonance form that we could have. Let's talk about the hybrid resonance. That would be the connectivities. The first thing about the charges is the nitrogens. If you look the nitrogens, they're all positive, so it remains n positive and positive for the hybrid resonance as well. Or you could do summing up +1, +2, +3, +4. 4 divided by the 4 would be again +1. If you concentrate on this oxygen down in the down left, you could bottom left, you could see -1, 0, -1, 0. So it's -2 divided by 4, and it's a half, -half, -half, and -half. Okay, and then again, if you look at that bottom left NO bond, single, double, single, double. So it's still flickering between a single and a double. So partial bonding here, partial bonding here, partial bonding, and also partial bonding here. That's the hybrid resonance for this structure. Okay, so that's what we get, and I want to discuss this further on with another structure. Let's see what we could do about that. Possibly getting yet another form. Let's talk about N3 minus, and that would be my last example. N3 minus have this sort of Lewis structure, and I do use ORFC. And if I do so,